Hello world, hello YouTube. I'm Rafael and just I developed the Raccoon engine, and this channel mainly has some devlog on how the engine was developed and stuff like that. But this video will be more of a walkthrough on the Raccoon engine. And ideally, it's more of like me talking about some of the design decisions, how to download the engine, basically like what are the different components of it, and I'm going to be trying to explain through a presentation kind of format, essentially like what it is, what are the different parts of it, and ideally so that you can make your own. The goal is that you will be able to use the engine for whatever you want to use it for. um so yeah, I'm super excited to talk about this, so let's just get started. So this is the GitHub repo, okay? So I'm gonna assume some basic knowledge of coding, but not much. So if you're like an advanced coder, then I apologize, but this is more like a general purpose. This engine does require a bit of knowledge on coding though, so definitely I would recommend you to first pick up Python or Java or something like that. Just practice coding, practice that kind of stuff, get your hands dirty, do a few programs, write your own kind of small games, and then come back here, okay? Because this is some of this stuff might be a little bit advanced if you're a beginner. But don't worry, I'll walk you through it. So, okay, so what is the Raccoon engine, first of all? So, the Raccoon engine, like I said, is essentially a game engine, okay, that I developed. And mainly I'll be walking through this documentation, and then I'll be going to the different places of the engine and expanding on this sort of stuff. So the first thing we might want to do though, before anything, is download it, right? Downloads, I guess. So if you wanted to, you know, download the Raccoon engine, you could very easily do that by going here and either hitting here, download zip. Actually, yeah, you want to go here. So you go to download zip here, and that's going to download basically everything, okay? Awesome. So now you're here, you have it. Feel free to extract it. And here it is. Okay, so if you go here, you basically have the engine. Now, this is basically, everything that's in here is the same thing that's here. Okay, it's just that this is a better format. So I will be going to the GitHub repo and I will be walking you through it through here. But once you have it here, I will personally later show you like what other tools and what other things you should also have to successfully run it, right? It's not much. It's literally just like an IDE for coding, and that's pretty much it. So anyway, so let me actually close. Let me, just get rid of this. I'm gonna get rid of this, and yeah. So okay, so the first thing is the introduction. So like I said, this is just what is the Raccoon engine. So the engine is mainly used, like it has at the core something like build engine, right? So if you guys know what the build engine is or the Doom engine, it's a basically inspired by Doom, the game, which was a really popular game in the 90s. It's basically a boomer shooter, right? So that's kind of the, I guess, the genre of those kinds of games. And essentially all it is that it's just that you have like these graphics that are really old school. There are some limitations, like it's not full on 3D, right? Like you have to be kind of careful about, um, you have limitations, and I'll get to that in a second. But exactly, yeah, I built this because I basically wanted to, build my own 3D engine, but I was just like, I didn't want to go full on 3D because writing your own engine from scratch is already kind of difficult, and I wanted to have like an advanced, powerful engine, but I didn't want to go full on 3D because Unity already has full on 3D, and also Panda 3D. That's a library for Python. That one's also full on 3D. So I was like, well, I want to build something that is kind of cool, and I always wanted to build that sort of boomer shooter, and I fell in love with the graphics from Doom and the build engine. So I was like, I absolutely want to do this. Anyways, so I did that, and I had a lot of free time, so I was like, okay, I might as well do it. So, Cool. So then the question is, how do you install it? Well, I just showed you, right? So at the end, I will actually go through the engine itself. Actually, I might as well do that now. So first is the installation of the engine. So like I said, the first thing you might want to do is go here and download zip. The other thing I recommend to do is to also go here. So here, download this one, eclipse.org. So again, you should go to a website, go to a YouTube link. I'll provide those links below, but basically it just shows you like how to download Eclipse. You want to get like Eclipse for Java. That's what I use. You don't have to use this. I think there's other IDEs, but this is the most popular one. And what it is just like where you're gonna write your code, right? And where you're gonna run stuff, right? So you need Eclipse for Java basically if you want to run a program. And the way Java works, there's a video on that, so I recommend you also look at that. There's a whole thing on Java. Okay, so again, I'm not gonna walk you through Java, through Eclipse, through okay. Like I assume there's videos that you can search on your own to learn about those tools. But basically, this engine, mostly I do my development in Eclipse. So you should go ahead and download Eclipse. Once you have Eclipse installed, right, you're gonna see something like this, right? So basically, if you just hit Windows, the Windows key, and you can search like Eclipse Java or Eclipse IDE. So for Java, you need to not only install Eclipse, but you should also install Java, JRE, all of that crap. Okay, there's a lot of stuff for Java, so I'll put those links below, like everything you need. But you need to install Java, you need to install Eclipse. And you should also install, by the way, you should also install VS Code. Like this, Visual Studio Code. Also install that. Okay, that one's also going to be useful for when we develop things in Lua. So I'll walk you through what Lua is, but okay. So I'm going to assume that by now, go ahead and do that. I assume by now you did. So I'm going to walk you now through the next stuff. Okay, awesome. So the next thing we need to do is essentially, again, so VS Code, so Visual Studio Code essentially, Java, Eclipse, that kind of stuff. And that's going to be useful because you need to run Java, okay? Now remember the thing about Java is that it's not like C, right? It has this whole, like, it's platform independent. That means that you can write code in Java and it's not just going to run on Windows, because C, there's like a specific application for Windows, you know what I mean? If you write code in C for Windows, then you're kind of stuck on Windows. You're going to have to rewrite something for other platforms. But Java is completely independent of the platform. That means that whatever you do here in the engine, it will translate to Apple, right? To Mac, Linux, Windows, anything that can run Java can also run your program. The only caveat is that it's a bit harder to launch, but there is a tool that will let you turn it into an executable, right? So there's also like a publisher thing. So I can walk through that in the end. But so anyways, this is the engine. So when you have Java installed, when you have Eclipse installed and Java and everything runs smoothly, you're gonna see basically this. What you want to do is go to like open projects from file system once you have it installed, and then you will go to the Raccoon engine directory. So if you go to directory here, you would go to like, wherever you have it downloaded. Wait, I'm not gonna, let me just get it here. Oh shoot, I already had it. Let me extract that again. So if you go here, right? So if you get it, what you would do to open it is you would go here, directory, and then you would go to wherever you downloaded it or wherever you have it stored. And you want to just go here to this Raccoon engine. Remember, it's not the first Raccoon engine because that's garbage. You're not going to see anything. You want to go to this one because this is where the project is. This is where the actual engine is going to run, where the bin is, right? So you want to go to this folder and then select folder. And then that's going to, you can walk through the stuff and that's going to basically show everything. Okay, so also while you were downloading the whole engine, I forgot one more thing you want to do is this says configure libraries. You also want to essentially go to so this tells you, right? So you go to Eclipse, build path, configure build path, right? So you would once you open up your stuff, we also need to get these libraries. So these libraries are going to be important for um, reading certain files like your Lua scripts, which we will get to what they are, but you only need those two and they're shipped with the engine. And all you're going to do is again go to right clicking on the project, just like it says here. So you click on this, then you go to where was it? Build path, and then configure build path. And then this opens up. You go to libraries, and then where it says class path, you would just be going here, and then you would click there and go here, add external, is it? Yeah. So you would click add external jars, and there you're gonna go to the library location, right? So I'm not gonna click it because I already have them, but you, well, actually, I'll just click it. You would go to downloads. Okay, I deleted it, but you know, if you have wherever you have it, like Raccoon Engine, here's where I have it. You go here and you add this one. You add this one, and then you add this one. You add both of them, and then you know you have them there, and then you just you hit apply, and then you're done. I'm gonna hit cancel because I already have them, but that's what you would do. Again, a class path, add external jars, and then do that. Let me cancel here. So yeah. And if you have all of that, then you just need to click run. So you would go to main. This main.java is like where the program, it's the start point, okay? It's the entry point, it's called, basically, to the engine. And you hit here, and you should see this, okay? You should see something like this. So it says hello world. If you see this, it means the engine is running. Raccoon Engine 1.0, F4 to toggle full screen. You should be able to like toggle and walk around with AWSD. So this is just like a very bare bones kind of like world. There's nothing here, just bare bones, but you know, something like that. But it's open source, so basically, you know, it's fully for you to use, to edit. Which is different from Unity, right? So Unity, for example, or Unreal. Well, Unreal, I think it's open source, but these are really big engines, right? Like you're probably not going to be looking at the engine itself. In this kind of approach to game development, like I give you the engine and the base, and you kind of like, of course, you don't have to change the engine. The engine is good as is, but if you want to have more power and change anything, you know, if you understand the engine, you can just do so much with it. So you could even develop, you don't have to, by the way, you're not stuck to doing boomer shooters, okay? I know I said that, but I was literally developing like a top-down game the other day, okay? You can use this engine for RPG Maker, visual novels, like it's, you know, absolutely. There's a lot of completeness in this engine. So you could use, it's a general purpose engine, but it's designed for boomer shooters. But you don't have to use it for that. Okay, this is gonna require a little bit of scripting, but so of course the bigger question that you're gonna ask is why Java? So the reason why I chose Java was because I really liked Java, and I already had written a different game engine that took me a while to make, using raycasting. So this is something like Wolfenstein and Wolfenstein 3D, right? So this used raycasting, so it's a bit different, but you know, Doom really upped the stakes back in the day. And well, I was like, well, okay, so C and C++, like it's great and it's super fast. The problem though is that one, it's platform dependent, but two is like, how do I put it? It's not so easy to pick up, okay? And I know C and C++, but when I was developing an engine, I kind of wanted the user to also be able to understand the engine and not have a hard time. And I feel like C and C++ is kind of difficult for beginners and just anybody, but Java is a lot more like, you know, friendly. So I decided to do Java. Also, you have automatic garbage collection. Java takes care of garbage for you. That's just a weird speak for coding, but don't worry about it. The point is that C++ and C, it's a pain in the ass. Okay, the next thing is, okay, so this is some of the stuff, some prerequisites. Okay, so this is the theoretical prerequisites for how to use the engine and essentially like um how to develop things correctly. So first of all, you're probably gonna need to brush up on math. Okay, so I definitely recommend to learn about algebra, just basic functions. You don't need to know a lot. Trigonometry. So you know this kind of stuff like sine, right? Cosine, right? So just kind of know like and tangent, right? So this stuff is really useful. Definitely, I'd recommend that stuff. And the inverses of them, usually written like this, right? And then the same for the other ones. Definitely recommend that. I'd recommend. So you really only need that, right? So triangles, right? Angles, that kind of stuff. I'm trying to think what else you need. No, I think that's honestly just a solid high school math. Honestly, just a solid understanding on high school math. Maybe linear algebra, just very basic linear algebra. I could point to that, but not a lot, just basic linear algebra. This is really all you're going to need to understand the engine. You don't even need this to develop games. It's just so that if you want to understand how this is done and you want to mess around with things, then, um, I would, this is how the graphics are basically rendered. Okay, the other thing is so this is just some of the terminology used for the game engine. So for example, the way you would first traverse the world would be through something called a digital differential analysis. That's just math speak for a faster way of checking whether there is a wall or not a wall, or whether there is something to render or not. Okay, so I'm not gonna get into it too much unless you guys want me to make a video about how exactly I did it. But you know, that's just kind of, so that I'm gonna point to a video that does DDD algorithm. And in the game engine, right? Just fun fact. Um, let me go here. So this is where all the files for the game engine are in screen.java. Right here. Oh wait, no. Right here. Cast, ray, and render screen column. This is where um, this happens, the DDDA algorithm. Okay, so this is very important because this is how you render the graphics and you render that kind of stuff. Okay, so the next thing is projection and scaling, right? So this is just basically, in graphics, usually the way you do graphics is through projecting things. I'm not gonna get into it. There's a video that I can link to that will explain that. But essentially, if I just like quickly explain this, the idea is that you have your screen and you have well, actually, let's just imagine that this is from the side. This is supposed to be like a retina kind of thing. This is the screen object. This is the screen. And, let's say you have a certain vertex, right? Or object in a 3D world, and you sort of throw like a line between them, and then you throw a line to that object, and you're basically projecting this object onto from the retina, right? This is what's called a focal point, to the object, to the vertex. And yeah, I mean, you're just projecting. So you're trying to find where should this object appear on your 2D screen, right? So in this case, it would be like around here, right? Maybe, And then as you move, it's basically trying to project a 3D world onto a 2D screen, right? So there's a lot more detail on that. There's like a bunch of YouTube videos that explain that in a lot more detail. Again, the goal of this video is just to walk through some basic things, and then the idea is you want to learn how to use the engine, right? So not go into the details for this, but I mean, if you want me to make a whole video on this, if you guys want me to make a whole video on this, I could, but otherwise this is going to be like 12 hours long. Okay, so then we have also portal rendering. So the way this engine particularly works is that it very much borrows from how the build engine works. I'm going to show a picture of Duke Nukem here. So interestingly enough, it actually is a lot more like the build engine than like the Doom engine, because the Doom engine uses something called a BSP, or a binary space partition, which is a faster way to render, right? Everything is just a question of rendering, like how to render things on the screen faster for graphics, because you have to do a lot of mathematics, and the idea is you want to do that quickly. So the build engine like avoids having to do a whole algorithm that is not so trivial to implement. And there's a much more easier way of doing it, which is through portal um portal rendering, basically, which is what it does is just, in a nutshell, is that it's that I'm just like using recursion in a way. Like, if you know what if you don't know what recursion is, it's just like a function calling itself, which I know sounds kind of um strange, right? Like, if this is a function, you know let's say, and this function returns so the same function, right? So what this does is that it returns this, so it calls itself, right? This is a weird pseudocode, but the idea is that, I mean, ideally it wouldn't return anything, but anyways, that's what I'm saying. Like, the idea is that's what recursion is. So what I'm trying to say is that in this particular rendering thing, is that I'm basically walking through each column of my screen, and that's it. Okay, that's the thing I'm doing. So if I open up my if I go to the screen here, you can actually see right here, cast ray and render screen column. There you go. And then X is the column right on that screen. So you would pass in, like, this would be screen 0, 1, column 0, column 1, column 2. And if a screen has about so what's the wide of the screen is like 640 pixels, right? So it's 640 pixels by 480, right? Some other resolutions are 1920 by 1080, but that's high definition. That's too much. That's way too many pixels for this to work. So we're only keeping it at 640 by 480, and then we're basically increasing the resolution. But natively, we're running at 640 by 480. But that doesn't mean you can run a full screen. You can absolutely just upscreen that, but upscale that, just using some math. But that's super easy. Anyways, we have this, and then you have all of the 640 columns that you want to render starting at 0. And yeah, so basically you would do that for each one. And then what you do is you run this thing, projection and scaling. Sorry, you do this photo rendering, which what you do is you walk through a whole world. And in that world, as you're navigating it through, you're checking, like, did I hit a wall, basically? Like, as you have a ray being casted from you to the world, you're essentially checking, like, did I hit a wall? You know what I mean? Or did I hit a portal? This is important because, if, for example, if I hit a wall, then how that wall gets translated to this is that it's going to project the wall. So let's say the wall is supposed to be here on the screen. Then it's going to say, okay, well, draw everything here on this column, and then everything above it, draw something, everything below it, draw something. That's basically what it means to do a wall. If you have something like a portal, it's basically how you would render something like a sector, right? So if I were to show you in my devlog example, you see how there is like rooms. You see what I mean? Like clearly here we're below, then here in this red area we have like a little bit above it. That's basically a column that says, hey, by the way, there is a portal to a new sector, to a new room, that you have to continue to recurse the same algorithm you just did for this room, but on that room. So basically, that's kind of how it works. Again, I'm kind of rushing through, but I could make a whole detailed video on how that works specifically because this is my own flavor of rendering. You're not going to find this anywhere else. I borrowed from the build engine, but I still did a bunch of things that are only specific to the Raccoon engine. There are some limitations with this approach, however, like for example, you can have rooms above rooms, but that's the same limitation that you have for Doom. So it's very 90s accurate, I guess. Another limitation is that you can't really look up or down because I'm using something called a fine texture mapping. This is a very specific name. But the idea is that it's not gonna let you look up or down. Okay, that's the problem. So you're fixed to like, not up or down, unfortunately. Doom also had this limitation. Duke Nukem had this limitation, and every 90s boomer shooter has this limitation. So this is also 90s accurate, right? All of the limitations in my engine are not new, okay? All of it is exactly how it was back then. So again, if you're trying to make the next Unreal Engine hit or the next Unity shooter, I would recommend you to go to Unity. This is if you want to actually learn, but two, if you want to make an actual accurate boomer shooter that looks how it was supposed to be looking, as if coming right from the day. Finally, you have a depth buffer. By the way, texture mapping here, it works really simple. You're just like getting you're dividing everything in columns the same way. So before, remember how we were doing the wall, right? Well, now imagine that I knew that this wall had this specific texture, or something like that. So then I take this texture and then I just simply like take its size and then I just scale it appropriately and I put that on the screen. So it looks, where it should be. Similarly, we have depth buffer and lighting. So this is just essentially like how far things are. And this is how I figure out like if a sprite or if an object is supposed to be in front of another object. This is also really useful for something like fog and lighting effects. So the farther you go, the darker things get, right? So you have that option too. Okay, thank you so much. And in the next video, what we're going to try to do is basically get our hands dirty. So I'm going to open up the editor, run a few, run something, create something in the game engine, and just kind of show you some quick kind of thing so that I can walk you through the flow of sort of everything. So in the next video we'll get our hands dirty and I'll basically talk about the rest of the stuff. So again, thank you so much for watching and I'll see you in the next one.